Hi, today we're going to talk about soldering. There's an abundance of information on YouTube on that, so instead of discussing basics, we will focus on common mistakes and things not to do. I will also share with you some useful tips and tricks that will greatly help you improve the quality of soldering process and extend the life of your gear. This is Ron Martino. While doing research for this film, I watched over 20 other videos and was surprised to find out that no one ever pointed out the most basic and common problem many newbies face. So you've decided to get into soldering, purchased a soldering iron and all that goes with it. But as you start working, the iron tip turns black, and the solder begins to curl into balls and refuses to stick to the components. This means your iron is overheating, which is not at all obvious if you're a beginner. So if you bought an iron without temperature control and are faced with this issue, first try unplugging your appliance and letting it cool down a bit. If you see the quality of soldering improve, then this advice is for you. The easiest way to solve the problem of overheating is to wire a diode in series with the heating element. Important: make sure the diode voltage rating exceeds the power supply voltage. However, if your intention is to get into soldering seriously, it would be reasonable to purchase a soldering iron with temperature control or a soldering station. Now that your tool is set to appropriate temperature, which is usually about 300 Celsius, make sure the soldering tip is tinned over its entire area. If you do not tin the tip, you will not be able to use your tool. You must always use the soldering iron with tip of correct size. You have to pick it based on the nature of the work being done. Do not try to solder tiny parts with tip that has large surface area, or vice versa. Use solder wire of appropriate diameter. It's not handy to solder small parts with a thick wire. If you're unsure, choose the wire of a smaller diameter. It's more versatile. If the wire is way too thin for the job, you can easily double or triple its diameter by braiding it. To speed up the process, use an electric screwdriver. The 0.5 to 0.7 mm wire is suitable for most cases, whether you're working on a personal project or repairing something. If you need to work on wires or cables, you can use solder wire of a larger diameter. Soldering quality mostly depends on the tip you use. It should look silvery and shiny. Never use a damaged or a poorly tinned tip. I personally don't like nickel-plated tips. I prefer copper tips. Copper transfers heat better, tins easier, and it can always be sharpened with a file or cleaned with sandpaper. This also means you can shape the tip as desired. Probably the only disadvantage of copper tips is burning out issue. You can purchase copper tips for most Chinese-made soldering stations. If you've never used one, I urge you to buy it and feel the difference. You'll notice that your soldering iron cools down less and also recovers temperature faster after contacting large parts. The plated tips that most soldering stations are equipped with nowadays, on the contrary, cannot be filed or sandpapered because that will destroy the coating. So those plated tips are basically disposable. When mastering soldering, it's important to learn to not overheat the wire insulation. When I worked as an electronics design engineer, our laboratory hired a student trainee as a PCB technician. He was very diligent, but he couldn't manage soldering a cable to a connector. The insulation would shrink on him and burn, and the wire itself forked into strands and created a short circuit across the connector leads. When you work on wires, always pay attention to the insulation. As a beginner, it's better to use heat-proof wires. You can Google PTFE wires. I fell in love with them as a child and still use them today. They may be a little bit more difficult to strip, but this is easily solved by heating the insulation with a lighter or burner. As you do it, do make sure to not breathe in the fumes. If you are working on a project that contains a lot of wiring and cabling, it would be wise to pick copper wires. Avoid white-coated silvery wires, however, because it usually takes more time to tin them. Such wires, in fact, may be made of different materials. It could be tinned copper, which is good, but in most cases it's a cheaper alloy often used in Chinese-made industrial cables. When I was building mining rigs, I came across some SATA power cables that contained white silvery stranded wires that could not be tinned at all. I then had to use a crimping tool in order to extend them and make connections. A very common mistake most beginners make is an attempt to solder without flux. The term flux comes from the Latin word fluxus, which means flow. Flux in soldering is a generalized name for a class of substances. It does not refer to any specific chemical composition. The purpose of flux is to facilitate the soldering process. It removes impurities and oxide film from the surface of your workpiece and helps solder join component leads. The flux also wets the surface. A good rule of thumb is to always use flux when soldering. Remember, there is no proper solder joint without fluxing. The cheapest and most popular type of flux is wood rosin, the same substance violinists apply to the bow. These days, most solder wires already contain it as an additional component in their core. You always want to buy solder wire with rosin. To make sure, look for the word flux on the label. If you use classic hard rosin for tinning, you can put some solder on the tip of the iron and just dip the wire into rosin. Then do the tinning. The second option is to feed solder directly to the conductor while tinning. The soldering iron and solder wire should be on the opposite sides of the workpiece. There's also this great thing called liquid rosin flux. It's really cheap, but it works flawlessly. It can even be used when soldering surface mount components, SMDs, if they are large enough. Or you can buy dedicated SMD flux for that. Liquid rosin also does a great job removing shorts between conductors that accidentally stuck together during soldering. Just put some flux on the sticking point and heat it with a soldering iron. After you've finished your soldering job, before powering up the circuit, don't be lazy performing a couple of checks with a multimeter to make sure the short was completely removed. You'll save yourself tons of time replacing the burned out components. And it goes without saying that you should never solder with power applied to the circuit. Even people with years of experience sometimes forget to cut it off while working on the PCB. Yep, that happens. So it never hurts to recheck if your power supply is off. Another very common way of removing excess solder from the workpiece is using a desoldering wick. The braid is placed next to the part to be desoldered and treated with flux. Then, as the heat is applied, thanks to the capillary effect, the solder from the contact pad gets absorbed into the wick. Another way of removing components from the board involves using a desoldering pump. This method is much simpler to master. However, it's also way less effective. You should try it and decide for yourself which way suits you best. To wash the boards after soldering, it's better to use alcohol because it has quite strong detergent properties while being the least caustic. If you use alcohol, your chances of harming your workpiece or yourself are close to zero. You should never use gasoline, kerosene, acetone, or organic solvent to clean the board. These liquids are toxic, they have a pungent odor, and may not be used indoors. While working on your piece, always use a reasonable amount of solder. Otherwise, it will drip from the tip and you'll be wasting it. On the other hand, a fair amount of solder at the tip of the iron improves thermal contact, as it effectively follows the shape of the part you're soldering. Or, if you are desoldering a part and it won't go, just put a bit more solder on the tip and it'll work. Always tin each part individually before soldering. This applies to any component: wire, connector, cable, electronic component, or a PCB trace. However, act according to the situation. There is no iron rule here, pun intended. For example, integrated circuits generally do not require tinning because they come coated in solder to prevent corrosion and oxidation. Copper conductors can sometimes be soldered without tinning at all, although I do not recommend it. There is a common practice of bending component leads to fix them on the board before soldering. In the 60s, this technique was especially popular. PCB technicians would even twist the leads to make the solder joint more durable. However, in a personal project, it wouldn't be such a great idea, since it would greatly complicate the desoldering process in case you need to modify or fine-tune your circuit. When soldering, we always face the problem of oxidation. The oxides are an insulator for heat, so you should never solder oxidized leads. Any wire stripped a while ago and left sitting on the table would be covered with oxide layer. So, it would be a great idea to cut that off and strip it once again before tinning. There also may be oxides on PCB traces. They can be cleaned with a regular pencil razor. In no case should you use a fine file or sandpaper to do it. The stripped wire ends should not be too long. In fact, you should make them even shorter, because insulation always shrinks during heating. Always twist a stranded wire before soldering, but never use your fingers, because grease may impair the quality of the joint. If possible, try to not touch your workpiece with your hands at all. Teach yourself to use tweezers. This will prevent you not only from leaving grease on the parts, but also from burning your fingers. Purchase quality stainless steel tweezers with a good hardening. If the tips of the tool you bought can be easily bent with pliers, and even more so with bare hands, such tweezers can be immediately sent to the garbage. Some people prefer medical tweezers. They are relatively cheap and are always of good quality. To succeed in stripping stranded wires, all you have to do is teach yourself to properly apply the force. If you squeeze the side cutters too hard while removing the insulation, you may cut off some of the strands. You just need practice. If you're a beginner, you will finally get the hang of it. In fact, as a child, I first learned to strip wires with scissors. I thought it was easier, so I learned to use side cutters for stripping much later. Strand cutting can get even worse when working on cables. Whilst removing the insulation, you may overlook the fact that the wires got cut at the very place where they exit the cable. If this happened to you, just pull the wires to the sides, cut off excess insulation, and then restrip the wires. In general, it is advisable to cut cables lengthwise. Even if you cut a bit deeper than necessary, as a rule, the knife blade will go in between the wires without touching and damaging them. Purchase this stripping tool on AliExpress. It can strip both wires and cables. It may need a minor adjustment, but it's not too difficult. Also, buy decent side cutters. In the store, if you have a chance, look through them and make sure the contact of the blades is perfect. Do not waste your time on poor tools. Always check the quality of the solder joint by wiggling and pulling on the wire or component. If you've done a poor job, the part will be loose and will come off easily. You must learn to evaluate the quality of your own work, so always do this simple test. If necessary, use a magnifying glass or even microscope. Make sure all leads are evenly filled with solder over the entire area and the soldering surface is smooth and shiny. There are active and non-active soldering fluxes out there. Active flux is generally used when a part fails to be tinned with conventional flux. I use aluminum soldering flux. It actually works in most situations where conventional flux doesn't. Again, it's important to not overuse it when unnecessary. You must remember that active flux vapors are much more harmful than rosin fumes. Avoid exposing your eyes to them and never inhale them. After soldering, be sure to rinse the board, as active flux residues can damage the PCB traces and component leads. If the room you're working in does not have a hood, you can use this simple method to capture fumes. Also remember to always wash your hands after soldering, lest the lead and other chemicals contained in solder wire accumulate in your body. Most soldering jobs require insulation. So heatshrink, a tube whose diameter decreases when heated, is very popular with electronics hobbyists. Note that the shrink ratio of such tube may be different and is always indicated on the label. Some typical values are 2:1 and 3:1. The higher the ratio, the more expensive the tube. You don't usually need high shrinking ratio, so there's no need to pay extra for it. While soldering, keep the tube away from the iron so it does not shrink prematurely. You can always use regular electric tape for insulation, and generally, the thinner it is, the better. Thick, rough tape is not really suitable for this purpose because it dries out quickly and loosens over time. Get in the habit of always isolating connections even if they are temporary. This will save you from accidental shorting. And there's also this cool thing called liquid electric tape. You can give it a try and see if you like it. Always match the size of the wire to the size of the part you're working on. Do not solder large heavy wires to small parts, as they can easily break off component leads or pads. If you need to solder a wire directly to the board, use as thin wire as possible. You can extend it later with a thicker one if necessary. A thick wire can tear off the PCB trace, especially after heating during soldering. If you accidentally do break a PCB trace, please do not attempt to make jumpers of solder. It's unreliable and it's bad manners. Always use a jumper wire for this purpose. If the component you're working on contains plastic parts, like most connectors do for example, you have to be much more careful during soldering. If you apply too much heat, the conductors may shift, effectively ruining your component. Temperature is one important factor when soldering, but duration is yet another one. Try to keep heat contact time to a minimum, but within reasonable limits so that it does not impact the soldering quality. Pins of a dip package chips should always be soldered by every other one and never in a row, preferably by every 2 pins, so that the heating of the semiconductor wafer inside the chip is uniform. Take breaks, allow the chip to cool down. When soldering integrated circuits, it's advisable to use a grounding bracelet. ICs are not necessarily damaged by static electricity, but I do remember seeing a few ROM chips deleted because of it. Although a flex cable somewhat reminds of a PCB, you may generally not use a regular soldering iron to work on it. However, if the underlying layer is thick enough, you may attempt it, but at lower temperature and shorter duration. But chances are you're just gonna make a hole in it with the iron, so you gotta exercise to succeed. And by the way, by overexposing a regular PCB to heat, you can also ruin it. In some cases, the damage is reversible, especially if it's a multi-layer PCB and it's next to impossible to locate and restore the impaired circuit. The basic soldering principle is this: the larger the part, the longer you have to apply heat to it, and vice versa. And one more important rule: unless necessary, do not solder over a PCB, especially over a computer motherboard. If you need to solder something inside a device without completely disassembling it, orient the case so that a random drop of solder does not fall on the board or the components, or protect it with a piece of cardboard. Remember, one tiny drop of solder may completely ruin your circuit, especially if it's powered. Also, do not solder over your hand or body without wearing clothes, especially if you're a beginner. Soldering injuries are not very serious, but still painful. Do take care of your eyes though, and be very careful when shaking the solder off the iron. Sometimes it can escape from the joint you're working on quite unexpectedly, so do watch out for that one. In some situations, it may make sense to wear glasses. Remember, you don't have extra eyes for replacement, so never skimp on eye safety. Never use your soldering iron to remove insulation. Apart from the odor and damage to the tip, the plastic remains will get stuck between the wire strands, which will impair joint quality. The method may be used when removing insulation from the coil wire, but never with regular wires. And I implore you, please do not use a soldering iron to make holes in plastic. Here's one more rule you've got to remember. Always use a stand. Do not keep the iron on the table. Do not place it on top of other objects. To avoid accidentally burning a cable insulation or a tool handle, always keep the stand at some distance from other items on your table. Do not place the soldering iron on the edge of the table. Hit the power cable with your foot and you make a hole in your flooring. It's also possible to accidentally touch the tip with bare hand if your table is crowded. Do not clutter up your desktop. Always clean up before a new soldering job. Years ago, I used to be in the habit of putting a soldering iron on top of a cup of tea. Never do this unless you really want to burn your lips. And one more thing. Non-copper soldering tips may not be sandpapered. The easiest way to clean such tips is use the yellow sponge that usually comes with your soldering stand or soldering station. Wet the sponge and gently scrape the tip across it. Rotate the iron, then scrape across the sponge again. You can use a household sponge for cleaning too. Some people use a metal brush, but I do not recommend this, as this can damage the coating of the tip. Make it a rule to never hit the soldering iron on the stand to shake off solder. You're gonna ruin the heating element. Shaking off can only be carried out in air. And allow me to remind you once again that it is crucial to protect your skin and eyes while you do it. Never cool the soldering iron in a cup of water. To avoid burns, never hold the items you work with bare hands. Always use tweezers or alligator clips. Many electronics hobbyists use a stand with alligators and a magnifying glass. It's quite handy. However, if you're up to saving some money, you can build one yourself. Just order alligator clips from AliExpress in bulk. They are really cheap. You'll definitely find a use for them later on. Some people also have a not-so-good habit of checking the soldering iron temperature by bringing it close to their face. Never do this, unless you want to burn your cheeks and nose. If you've just bought a brand new soldering iron, check it for leakage currents between the tip and either power lead. This issue is not obvious for most people, because the handle of the soldering iron is always insulated and the probability of electric shock is close to zero. However, if your tip is not properly grounded, you can damage the circuit and the components you're working on. If you see a spark when the soldering tip touches your workpiece, immediately disconnect power supply from the iron and find out the cause of current leakage. Okay, now it's time for some life hacks that you may find handy while soldering. To prevent wires from coming off the connector or board, fix the newly soldered cable with a knot or tie, which will hold it in its place. Factory-produced devices like power supply units, video cards, motherboards, etc. are often soldered with high-temperature lead-free solder. Such boards will have a designation, the crossed-out letters PB, plumbum. To succeed in desoldering parts from them, mix your solder with the original solder on the board. This will improve thermal contact, and the part will come off easily. You may not use your tools, like tweezers or a screwdriver, to apply active flux to the workpiece. The chemicals it contains will eventually destroy them. The flux will also stick to other objects, including the surface of your table and the skin of your hands. So, use the solder wire to apply the flux. As you do the job, you dispose both of the wire and the flux. When using a desoldering pump, wiggle the component leads from side to side with tweezers or fine pliers. At some point, you'll feel that the pin is free from the joint. Once all of them are, you can easily remove the component from the board. This technique significantly speeds up the desoldering process. 2-pin and 3-pin components are desoldered by tilting the part from side to side. If the component takes significant time to desolder, you risk overheating it. So take a pause, let it cool down, and then go on. Remember, your goal is to salvage the component, not to destroy it. ICs in a DIP package can be desoldered with a dull needle. Cut off the needle-pointed tip and make it blunt. Then deepen the needle into every contact pad while heating it with the iron. As you free all the pins of the chip from solder, you can safely remove it from the PCB. If you need to solder a lot of wires for your project, you can speed up the process by combining soldering with heatshrink application, like this. Sometimes it's easier and safer to cut out the whole chip instead of desoldering it. I can confirm that components can actually fail due to overheating during soldering. Press the handles of the side cutters slowly and gently. Otherwise, component leads may break off the body due to mechanical impulse. Leads may also turn into projectiles as you cut them. Remember to protect your eyes and skin as you do it. If the chip leads are too short to be cut off, you can cut out the entire IC along with a piece of the PCB instead. Just extend the pins with wires. Use cut-off resistor leads to do it, then solder the IC in place. To clean the vise from solder, you can use a sharpened match. A steel needle may work too. It is known that high-frequency coaxial cables may not be extended, since it results in loss of signal. However, you can restore a broken coaxial cable by soldering the central conductor and then insulating and wrapping it with a stranded wire, as if restoring the shielding in its original form. Heatshrink can be installed on top. This way, I managed to successfully restore high-frequency GPS receiver cables. The newly restored cable demonstrated excellent performance and worked perfectly without any signal loss. And here's the last piece of advice. How many times have you forgotten to turn off the soldering iron, had to run home and recheck, or sat at school or work worrying? Power your soldering iron from a table lamp, then you'll never forget to turn it off. And if you also have a smart lighting control installed in your home, This will be taking care of itself automatically. If you are interested in purchasing soldering gear and accessories shown in this video, please check the description section for links. And if you like this video, please don't forget to comment, share and subscribe. This was Ron Martino. Be good.